Welcome to our screencast for today. In this episode, we're going to take a look at a very well-known and common solution to search engine optimization with Ruby on Rails, but we're then going to do something far more interesting and extend that to demonstrate how we can obfuscate our ID numbers from our database, actually encrypt them, so that we're not leaking information out, and also to help to do a little bit of protection against tampering with those IDs. So let's jump right in here. We have a very basic application here. This application simply has some questions, and those questions have a bunch of linked answers. Very basic. As we click through though, of course, you can see, as is typical with any Rails or really any RESTful based or style system, we've got the ID number for the database sitting right up in there. And any user, if they know just a little bit about this, knows that they can simply add actions to that and do all kinds of things to begin to manipulate that data. But they also have the ability to look and say, if I'm looking at question or answer number 4, I'll bet that there's an answer number 2. Now, how to prevent that kind of activity and the revelation that there is more data, we'll talk about that in a little bit. Let's first deal with, how do I get more information up into the URL? Because right now, the only thing that appears when I go to question 1 is the 1. And for search engine optimization, it would really be ideal if we could get this text up here in the URL, because then we'll get many more hits to our site. Or at least that's the theory. To solve this problem, as I said, it's actually a well-known and long-time solved problem. Actually, let me just stop Rails there and open up my Ruby, my TextMate. It's a well-known and easily solved problem. All we need to do is make a change to our model. So let me go into the question model here, and we simply need to override the toParam method. Now, the toParam method is part of the active record base, and it's actually going to be returning, by default, self.id. We can override this to return anything we'd like to. Now, just for proof, if I leave this alone, so I just return self.id, I come back in here, and and of course I need to restart Rails here. So Rails S, come on back. Of course I can load up the site still, I can go back, and when I'm looking at these links, they still all work just fine. Now, what does toParam have to do with that, you may be wondering? Well, it turns out that whenever you're using a link to or anything that generates a path, it's actually using toParam to figure out how to parameterize that ID. And it simply asks each object, what is or how do I parameterize you? So self.id is the default. We can simply override that into anything else we'd like. So let me start by simply encasing this inside of a string, and now I can add other data to it. Now, you might be tempted to simply pop in the rest of the data right here, but that's a big mistake. Because let's imagine that we had some element within our database, a question in my case, and instead of saying, my question is, instead it started with a number. If it starts with a number, it is going to corrupt this ID number because it will be interpreted as part of the ID. So it's best practice to simply add a dash there or something, and now we'll put in what we actually want to display in the URL. So I'm going to use the question, which is actually the attribute in this particular object that represents the question being asked. I can just do that, but it's not going to be quite good enough. Let me go back and refresh this page. And when I do, you'll see now that down there at the bottom, or up here in the top, I have successfully modified the URL, but it's not very attractive because we've got these %20s all over the place. Of course, you're familiar with the fact that that's URL encoding of those hexadecimal values. Rather than using plus signs for spaces, it's used the %20. Easy enough to solve. We could simply come in here and do a gsub, and we'll search for spaces, spaces, and we will, no, that was right the first time, spaces, and we will replace them with, how about dashes? We'll just reload that page, and actually go back, sorry about that. And now when I click on it, instantly we have dashes. So a huge improvement, very, very easy to solve. Like I said, this is a well-known solution to this problem. You may be curious, though, if you're not super familiar with this, as to why this works at all. Because really, there is nothing in our database that has an idea of 1-this is a question. Well, the reason that this works is that while toParam is returning the ID or how we'd like that ID parameterized, when we now try to do a find, it's essentially going to take the ID that comes back in the parameter and cast it into an integer, which means that we could actually put anything we want over here, anything at all, and it won't matter. Oh, whoops, I got a little too carried away there. It now tried to go and get that off of Google. So let me just, whoops. Did go too far there. Let me try one more time, see if I can replace that with HTTP. There we go. And it will return that question just fine, because it's casting it to an integer. Essentially what that means is that it begins parsing the string and takes all of the numbers it finds, but as soon as it finds something that's not a number, that is essentially lopped off, and that is the only thing remaining that is still searched for. Okay, easy solution. We can now do search engine optimization. I leave it to you to create a more generalized form of that you could put into a module or something like that to apply to all of your models. But we'd like to take that example of solving the search engine optimization and extend it to the problem I mentioned earlier. I said that an enterprising user could look and say, if I'm looking at answer number 3, I'm going to guess that there's an answer number 2. Now in our application, that doesn't matter. But if we're building a high security application, it can very much matter. And of course, we should have robust access controls within our application so that users can't view elements that they just arbitrarily type in by using forced browsing. But still, we might even be concerned that users should not even know how many answers there are. Or to make it something more practical, perhaps we have a user database and we have 400,000 customers. I don't want one of my competitors to be able to register for an account and immediately know I've got 400,000 customers. And the way they know is just looking at the ID that shows up right in that URL. So how can I obfuscate that or do something to it to make it harder to see what's happening there? Well, an easy approach, a very, very simple approach, would be to try to base64 encode it or something like that. But simply encoding it is really not a good protection, because anyone can simply base64 decode it. I would also steer you away from doing any kind of a homegrown sort of encrypting solution to this, because generally encryption solutions that we create privately are just not going to be as good as what we come up with if we use tried and true algorithms. So instead, let's take a look at a solution to this file, or to this problem. Now, to solve this problem, here's what I'm going to do. I'm going to paste in a little bit of code. I just don't want to type all of this in. And of course, I don't want to type it in and get it wrong. So I'm going to paste in a replacement for toParam. And I think I've got one too many, let me just indent this. I think I've got one too many N's there. Yeah, I sure do. So let's just take a look at this and explain what it's doing. And to do that explanation, I'm actually going to go back over to my Rails application and go back, and actually I want to go over to questions. And when I do, and look at or highlight the individual item here, note that in the browser bar at the bottom, or if I click on it up in the URL, this is now the ID that it's showing me. It's actually been encrypted. Now, right now, this application is really searching for something that's ID 32 for the reasons we've already mentioned. Everything else after this is not a number, but it's actually an encrypted value. Let's take a quick walk through this and explain what's happening. First of all, we're grabbing the ID that we started out with. So whatever ID is, we're simply converting it into a string, because all of our encryption algorithms really do prefer to work with strings. After that, we simply create a new cipher. We're simply using the standard library version of OpenSSL that comes right along with Ruby and, of course, naturally, Rails, and setting it up to use an AES cipher with a 256-bit block and cipher block chaining. After that, we set the cipher to be an encrypting cipher. We'll see that the complementary decrypting is going to happen somewhere else. Next, we have to set the cipher up with a key. The key really is just the password that's being used to encrypt the data. But if we encrypted the same data multiple times, it would end up looking exactly the same way every time it was encrypted. So we also have the ability to include an initialization vector, and this is where you would add some randomness into what you're doing. For instance, what you might do if you've grabbed maybe the browser ID or maybe a fingerprint of the browser, or perhaps it's the logged in user and you're using his actual database ID to perturb the encrypted values. If you go that route, it means that no two users will have any URLs that are identical. Really secure. But for what we're doing right now in this demonstration, just not worth our time to engineer. So I'm going to set it to be a static initialization vector. Now this next line, this is where the guts of it really happens. So let's take a look at what's happening here. And I actually see I've got an extra line here too. Let me just chop this out so it's not going to be confusing us. Get that out of there. So let's see what's happening here. So we're telling it to go and encrypt the ciphertext. And I'm actually going to start on the inside and work my way out. So the first thing we're going to do is tell it to update the cipher. In this case, since it's set to be encrypting, it will encrypt the data ID, and to then add in any padding that's necessary to make this of the appropriate block size, because it's a block cipher. Block ciphers require things to be of very specific sizes, so this just takes care of that for me, nothing I need to do. So essentially, this center block here encrypts the data. But that encrypted data is not going to be in a usable form just yet, because this cipher will absolutely return binary data, and binary data is not going to do very well in a URL. So our next step is to simply base64 encode that data. That's easy enough, so that should be easily digested in a URL. However, within that base64 encoded data, you will have things like plus signs and forward slashes. The forward slashes can be quite dangerous for Rails because it can end up interpreting things as actions that we didn't mean to, and the plus signs can be dangerous too because we could end up with our browser interpreting those as spaces. Now, it turns out that many browsers will be okay with those two characters, but particularly if our users are using Firefox, Firefox will go and interpret that data. So if we were to simply escape this using the rack CGI escape utility, which will turn them into hexadecimal values, it might work in things like Safari and Chrome, but if we tried to do it in Firefox, our application would suddenly break. So I'm simply taking the base64 encoded data and further encoding it, replacing slashes with asterisks and pluses with underscores, which are both valid HTML characters or HTTP URL characters, but are not valid base64 characters, so I don't have to worry about collisions. Finally, I'm running a chomp on that just to take off the new line character that base64 is going to add on. And lastly, encoding that whole thing. For instance, in base64, if I switch back over here, you'll note that at the very end here I have some %3ds. That's representing the equal sign, which is being used to pad out, right down here, pad out the ending of that base64 encoded data. All right, so that's how it got encrypted. How do we handle that? Because clearly right now, when I click on this, it doesn't work. Well, again, I've got a little bit of code that I've written ahead of time. I'm simply going to copy that, and we're going to paste it now into the controller's application controller. Now we're going to temporarily break our application for answers, but fix it for our questions. What we've done here is created a begin and rescue block. The top part of this, if you look at the first few lines, is nearly identical to our encrypting. The main thing that changes is that we set the cipher to be decrypting. The next thing that changes is that we're essentially unrolling our encryption. So note that in the very center here, we begin by unescaping, converting our asterisks and underscores back to slashes and pluses. We add in the cipher final. We then base 64 decode it, and finally update the cipher, which, since it's now set to decrypt, means that it will decrypt the data. I'll come back to what's happening over here in just a minute. So, and finally, we take the decrypted data and we assign it into the ID value in the params hash. Okay, so let's see if that's fixed our problem. I reload and instantly we are now reading question number 2. If I go back, this is a question. We're now reading question number 1, but again, notice what the ID looks like here in the URL. Completely unintelligible. It's an encrypted value. Now, can a user from this tell that there is another question? Absolutely not. But even better, if the user changes something here, now we get a problem. The problem I'm getting right now is undefined no local variable or method tampering, which you may have noticed here. I had return tampering and false. So let me come back over here. Let's define tampering. So this would just be another catch method, tampering. Let's say redirect to, I'm going to make it very simple for us, questions. Before that, let me set flash notify equal unauthorized and end. Alrighty, let's try to reload that now. And oh, I'm apparently not displaying the notifications up here, but it has redirected me, and that would now do a notification saying, oh, you've tried to tamper with something. So we're simply doing a catch or a rescue down here, and that's what this rescue is about. It turns out that if you've created other error handlers within your application controller, it's probably not going to catch this, because this is not going through the typical application controller error handling. So instead, we need to specifically rescue the cipher error, and that will occur when someone actually tries to tamper with that session, with that ID. Just a point of curiosity, it turns out that the user could really add things to the end here, and it won't affect it, because it's going to be decoding that base 64 block. So as long as they haven't gone too crazy here, things will work just fine. If they do get a little out of hand, it's eventually going to break it again. But what we come back with once again is a cipher error. So it turns out to work extremely well. So far though, we've only solved this problem for the questions. Right now the answers are still using the normal IDs, and when we try to decrypt them, it doesn't work because they're not encrypted. So how can I generalize this solution so it fixes it for my entire application? Well, to do that, I want to start by stopping Rails, because I am going to need to restart it when I'm done with this next change I'll make. And what I'd like to do is come over here and remove the toParam function. I'll just chop it out completely. Next, I'm going to go into my lib directory, and I'm going to create a new file called Encrypted IDs. Save that. And this will be a module, Encrypted IDs. Just camel case that properly. I'll paste my toParam in here, and we've now created a module. Now to reference that module, I do need to include it here. So let's include Encrypted IDs, and we'll simply include that line in all of our models. One last change needs to be made. I need to come over into my application configuration. Here we go. And I need to require that file. So that file, here's an easy enough way to do it. I'll just paste it in here. That file will be found right here. So that will expand it out based on my current path. If I restart Rails, come back into my web browser, just reload here. And yeah, it's not entirely happy yet. my machine is a bit on the slow side trying to do these recordings. There we go. It's okay. But now when I'm looking at my answers, you'll see my answers too have encrypted IDs, and transparently, these all work too. And by the way, you may be thinking, well, that works for that. That's fine. But what if you wanted to edit that? No problem. It becomes completely transparent. So there's nothing you need to worry about beyond actually making these changes. And you'll also notice, if I go back for just a second, that I'm still able to do references to IDs like I am right here. No problem at all. And it recognizes that that's connected to question number 1. And the thing that made that possible was, again, that in our application, we are keeping the IDs normal within the database and simply encrypting and decrypting them as they get presented to the browser, making a completely transparent solution. Now, I hope you do find that useful. If you do have any questions about it, you're welcome to reach out and contact me, and I'm more than happy to provide a copy of this sample code for you if you'd like to. Hope you enjoyed the presentation and look forward to our next one.